x squared plus y squared equals 25. Well, it has been a while, but do you remember this equation? This equation is represent a circle. Right? Circle, where is the center? X squared, y squared, so center is 0, 0. What is the radius? Radius 25 is 5 squared, so r equals 5. So, let's graph this circle. Center is 0, 0, radius is 5. So, 5, 5, 5 to the west and 5 to the south in all directions. So, you connect this nicely and make a circle. What kind of symmetry do you see? Well, all kinds of symmetry over here. Symmetry about the x-axis, symmetry about the y-axis, and the symmetry about the origin also, because it goes to the opposite, complete opposite direction. Okay? So this one has all kinds of, this is a symmetric about the y-axis, x-axis, and the origin. Okay? The next one is, yes, symmetry with respect to the origin. Yes. As I said earlier, symmetric about the origin. So x, comma y, and negative x, comma negative y. So if x, y are in the graph, that means negative x, comma negative y must be on the graph as well. Okay? So example 6. Testing for symmetry with respect to the origin. A, y equals negative 2x cubed. Let's just plug in any number. So x comma y. So let's plug in x equals 1. If you plug in x equals 1, what is y? Y is negative 2 times 1 cubed equals negative 2. According to this, in order to be symmetric about the origin, yes, when you plug in x equals negative 1, it has to go to the opposite, which is positive 2. Let's see if it happens. Y equals negative 2 times negative 1 cubed. Here we go. Negative 2 times negative 1 cubed is again negative 1. So that gives you positive 2. So x coordinate go to opposite, and at the same time y coordinate goes to the opposite. Therefore, this is true. Okay? So that means the graph is symmetric about the origin. About the origin. Well, the graph of this function will look like this. Negative 2x cubed will look like this. Okay? So for example, 1 comma negative 2 is over here. 1 comma negative 2. And the other side, the opposite side is going to be negative 1 comma 2 is on the graph. What about part B? Y equals negative 2x squared. Y equals negative 2x squared. Yeah, again, I'm going to write down if x and y on the graph and negative x comma negative y is also on the graph, that means the function is the graph is symmetric about the origin. Well, let's select. Okay, when x equals positive 1, what is y? Y equals negative 2 times 1 squared, which is negative 2. On the other hand, if you change it to x equals negative 1, what is y value? Y value is negative 2 times negative 1 squared, which is what? Positive 1. So negative 2 times positive 1, again the same negative 2. Well, what do you think? X goes to the opposite as over here, but y stays the same as negative 2. So it does not go to the opposite. Okay? So we can say that this function, the graph, is not symmetric about the origin. Okay? So about the origin means those coordinates will go to individually to the opposite. Okay. Well, test for summary over here. We can see x-axis, y-axis. Okay. Symmetry about the x-axis, about the y-axis, about the origin. Over here, equation is unchanged. Unchanged. Y is replaced with negative y. Okay? So imagine symmetry is about the x-axis. So pick one point. For example, here is 5, 2. Here, symmetry about the x-axis, that means this point will go to what? 5, negative 2, isn't it? So, the equation is unchanged if y is switched to negative 2. Okay, y is replaced with negative y, it's going to be the same thing. Okay? X is the same, so we can say y is replaced with negative y, the equation is unchanged. On the other hand, you have a symmetry about the y-axis. So this time, so let's say you have a point 2, 3. Symmetry about the y-axis will make it what? Negative 2, 3. So this time, the equation over here is the point is x is replaced with negative x. The y will remain the same way. So equation is unchanged. So we say x is replaced with negative x. On the other hand, the symmetry about the origin. So let's say again, here is, let's say 1, 5. Here is negative 1, negative 5. So if something is symmetric about the origin, that means the equation is unchanged. So this time both x is replaced by, well, replaced with negative x, and at the same time y is replaced with negative y. The equation is still same. Okay. So in terms of graph, okay, in terms of graph, this symmetry about the x-axis is like over here. What kind of shape do you see in the lecture note? That is, we call it ellipse. Looks like some lemon. They're oval shape. Yes, we call it ellipse. Well, y-axis. Well, it's coming next section or next lecture. Then we call it a parabola. Okay, it's a parabola. This one has a symmetry about the y-axis. And over here, the last one, we have a graph. Like this. In this case, this one will go to the opposite over here. So in this case, the graph is symmetric about the origin. Yes. Okay, so there are three types of symmetries. Symmetry about the x-axis, symmetric about the y-axis, and the symmetric about the origin. Among these three types, guess what? When the graph is symmetric about the x-axis, this is not a graph of function. Okay, so when you talk about function, you are not going to see symmetric about the x-axis. All right? So let's go to individual function graphs over here. The very first one. The very first, we call it f of x equals x. You see, input x, output x, the same. So we call this identity function. Identity function. Of course, everybody knows a graph. The slope is 1 and it goes through the origin. Well, as you see, this domain is from negative infinity to positive infinity, range as well. Range also negative infinity to positive infinity. And f of x is x equals x is increasing on its entire domain, which is this. It is continuous on its entire domain. There is no hole, no gap, okay? Again, on the domain from negative infinity to positive infinity. And yes, it's an odd function. Guess what? X is x to the 1 power, which is just only one kind of power, that is an odd power, so this is an odd function. Okay. Next one is squaring function. Yeah, f of x equals x. That is too simple. So now, this time, you have f of x equals x squared. Okay, x squared. Let's, to figure out the graph, let's make a chart. X values and the y values. When x equals 0, y equals 0. When x equals 1, y equals 1. X equals negative 1, same value, y equals 1. 2, 4. When x equals negative 2, y is again the same, positive 4. Well, what kind of graph do we expect? It's not going to be a straight line. Let's plot 0, 0, 1, 1, and here is 2 and 1, 2, 3, 4 over here. So it is going to be a little curve on this side and the other side also a little curve, looks like that. Okay, so same 1, negative 2, same 4. That's why it has a mirror image of this side. Okay, so first of all, This is a squaring function, and the graph, we call it a parabola. Alright. So here we go. What is a domain? Domain is a collection of all x values. Yeah, we can square every number, alright? So the domain is not a problem. All the real numbers can be in this domain. What about range? Well, when you square a number, the result is not going to be a negative number. That's why the graph does not go below this x-axis. Okay, does not go below the x-axis. So what does that mean? This range is the minimum of y value is 0 or positive. Therefore, range is from 0 to infinity. Okay? And in terms of increasing and decreasing, f of x equals x squared decreases, the function goes down over the interval, decreases over the interval from negative infinity to 0. Whenever you talk about increasing or decreasing, we are going to use open intervals. So in other words, well, we are not going to have a bracket over here. Everything is just round open. What about increasing? The other side, the positive side, the function is increasing from 0 to infinity. And it is continuous on its entire domain from negative infinity to positive infinity. Yeah, there is no gap, no holes in here. And another important thing over here is this is an even function. Did you see? The graph is symmetric about the y-axis. Yes, so this is an even function. Another way to say that this is an even function is, yes, this is a polynomial function with one power, that the power is 2, it's an even number. Yes, this is an even function, okay? So make an example of an even function with y equals x squared. This is a very important thing, and the range is from 0 to infinity. Well, go to the next function. This is, this time, well, cubing function. So f of x equals x to the third power here, cubed. So we call it cubing function. Well, the graph, what kind of graph do we expect? So x values and y values, corresponding y values. When x equals 0, y is again 0. When x equals 1, y equals 1. When x equals negative 1, does it stay the same? No, I don't think so. Negative 1 cubed is negative 1. When x equals 2, is 2 cubed is 8. When x equals negative 2, negative 2 cubed is negative 8. Okay, so in terms of graph, over here is 0, 0, 1, 1, negative 1, negative 1 over here, and 2, 8 going all the way up here, and here is negative 8 all the way down here. So the graph is very, very rapidly increasing. You see, very rapidly increasing. Over here, the other side like this. But again, when you read the graph, we read always from left to right. So that means the function is increasing on its entire domain. Okay? So here we go. This is a cubing function, so y equals, you can say, x cubed. What is a domain? Well, we can cube any real number. So in other words, all real numbers are in the domain here. What is a range? Unlike this squaring function, this range is from negative infinity to positive infinity. And it increases on its entire domain of this from negative infinity to positive infinity, and also continues on its entire domain. And what kind of function is this in terms of odd or even? Well, look at the power 3. Only one kind of power that is odd. So this is an odd function. Next is finally we are going to see some radical sign over here. So very first radical, which is square root. Okay? Square root, and the next one we are going to see cube root. So f of x equals square root of x. You remember, I emphasize pretty much whenever you have a radical, with the expression under the radical, which we call it a radicand, this radicand has to be greater than or equal to 0. So when you have f of x equals the square root of x, the domain is automatically this, x is greater than or equal to 0. Okay? So let's look at the graph. Okay. Well, make a chart. X and y. Well, 0 is the smallest number you can put in. Okay? X equals 0, square root of 0 is 0. When x equals 1, square root of 1 is 1. I'm going to jump to 4, because the square root of 4 is 2. 9, square root of 9 is 3. 16, square root of 16 equals 4, and so on and so forth. Correct? Okay. So this time, is this function increasing rapidly or not so rapidly? So let's see. When x equals 0, y equals 0. When x equals 1, y equals 1. I'm going to make it here. When x equals 4, y increases only by 1. So 1, 2, 3, 4, and just going over here 2. You see, twice as tall. 5, 6, 7, 8, 9, and then finally it becomes like a 3 over here. So what does the graph look like? Well, connect these dots. Yes. Okay, you are going to see that it is very important.